Video solving this is the green packet. It says yellow, but we ran out of yellow paper. The green packet from Recitation on Thursday. We're going to be using mass spec, IR, and NMR to determine what molecular structure or which of these molecules this thing might be. So set the scene. You work at an airport and someone is accused of smuggling a clear liquid through security. The passenger says it's rubbing alcohol, but the TSA agent suspects it's nitroglycerin. Based on the spectra below, who's correct? Okay, so the first nitroglycerin structure I gave you because I didn't expect you to know that. But I could give you, I didn't give you isopropyl alcohol because you should remember that propyl is 3 carbons and isopropyl makes this Y shape. So isopropyl alcohol, which is rubbing alcohol, looks like this. So the first thing I'm going to do, if it's me trying to solve this, is I'm going to look for what are important bonds that we're likely to see in our IR. So the major bonds that we'd see in our IR, we always see carbon-hydrogen bonds, so those aren't the most helpful. We don't usually see carbon-carbon bonds because they show up in the fingerprint region. Again, not very helpful. So all these carbon-carbon, carbon-hydrogen bonds are not helpful. And I actually think nitrogen-oxygen single bonds maybe come up in the fingerprint region, but I'm pretty sure nitrogen-oxygen double bonds come up around 16 to 1800. So we'd expect to see nitrogen-oxygen double bonds. For this one, we would expect to see an oxygen-hydrogen single bond. So that's kind of what we are expecting to see. There's no other major bonding that I see. Nitrogen-oxygen single bonds I don't think would be helpful. So this is what I'm looking for. And what else do we know is that if we have things involved in hydrogen bonding, it's usually going to be broad. So our alcohol is probably going to be broad. So I'm going to look first to my IR and see what peaks am I seeing. And I'm seeing, oh, I forgot to say what the chemical shift of these is. Nitrogen-oxygen double bond, I think that one shows up around 1600. This one shows up above 3000. Usually I think it's like 3200. And then carbon-hydrogen shows up around 3000. Sometimes it's, I think, maybe a little bit less than 3000, but I'm not for sure. So I'm going to come down here and look, and sure enough, we have our carbon-hydrogen and our oxygen-hydrogen. I'm pretty sure that's what those are. Let me look at my spectroscopy notes just to make sure I didn't flip those. Okay, yes, carbon-hydrogen around 3000 and oxygen-hydrogen shows up around 3200 to 3600. Great. Okay, and I'm guessing that the oxygen-hydrogen is less broad and less intense because there's just less of them compared to the carbon-hydrogen bonds, because that's pretty intense for the carbon-hydrogen bonds. So those are the only 2 peaks that we see. So off to a good start. I'm thinking it's probably not nitroglycerin. That's what I'm thinking. But I want to make sure it's not nitroglycerin. So let's draw in our hydrogens that we would expect to see. There's 1 hydrogen here, 2 hydrogens here, 2 hydrogens here. And I don't see any other hydrogens. I see that there's some symmetry. Like if you cut down the middle of this molecule right here, these 2 peaks are in the same environment. So I would expect, or those 2 hydrogens are in the same environment. So I'd expect only 2 peaks on the nitroglycerin structure. For the alcohol, and I would actually expect them to both be maybe in the alkyl region, maybe not though, because they're next to oxygen, which is pretty electronegative. But these 2 are in the same chemical environment. There's symmetry present there. So I'd expect 2 peaks there. If I was looking for the NMR of this, I would expect more than that. There's 1 here. Oh, I keep trying to draw this in blue. 1 here, and then 3 here, and 3 here. So again, I'm seeing these are in a very similar environment. But this one And this one would be its own unique environment, but then we have an extra peak that would be the hydrogen. So I'm already thinking it's probably, I said it would be the hydrogen, but it would be the alcohol. I'm already thinking it's probably this bottom one before I even look at the NMR based on the IR. But let's go look at the NMR and see how many peaks there are. Okay, I'm seeing 3 peaks here. So that makes me think it's definitely the isopropyl alcohol. Let me redraw this. OH, there's an H here. 3 H's here. 3 H's here. That looks crazy, but okay. So this is our structure, and we think that these green ones here are all one environment. So they would integrate to 6. Not that we have the integrals, that doesn't even matter. And they have one neighbor. This neighbor is there all in the same environment. So you look at the carbon next door. There's only one hydrogen on the carbon next door, so N+1, so that would be a doublet. And this is an alkyl, so I would expect it to show up 1 to 2. Now this next hydrogen, I think we did that one in orange, maybe purple, but I think orange. Okay, so this next hydrogen that integrates to 1. It has 6 neighbors, so 6 plus 1 would make it 7, so it'd be a septet. You could just say multiplet there. And it would start on the 1 to 2 region, but I think it would be left shifted pretty far because it's close to this oxygen, so probably even 3 and above. And then this last one would integrate to 1. It would be in the 4 to 5 region, and it would probably be broad from hydrogen bonding. So I see 3 peaks that match this description. We have our, is this a sextet? Maybe, but it's definitely a multiplet with these 2 baby lines right here. You can barely see them. This isn't how IRs really look. If you go watch my other video from the pink packet, there's usually a lot of noise here, but there is a little tiny baby one there. So we have a multiplet, and we don't know what it integrates to, but we have 1 multiplet. We have one singlet. Our hydrogen would be a singlet, and it's in the 4 to 5 region. Sorry, let me just label these. So I think this one goes with this because it's a multiplet, and it's shifted to the left because it's next to an oxygen. We have these green over here go with this. That is a doublet, and it's a big peak, so it probably has a higher area under the curve than the other 2. But a doublet we expected to see in the 1 to 2 region. And then we have this last purple one over here. We would expect to see 4 to 5 region and integral to 1. We don't know our integrals. And it would be a singlet because it has no neighbors because of that heteroatom in between. So I'm pretty confident this is isopropyl alcohol and not nitroglycerin. But the last thing we need to check is our mass spec. And honestly, you could have solved this just by looking at the mass spec because you're going to expect a peak that's about as big as your, that is about the same mass of your structure. So you can look up isopropyl alcohol mass. You don't even have to calculate it. You can look it up. It's 60 grams per mole. And look at what we have here, a peak at 60 grams per mole, which is the mass of our isopropyl alcohol. Now I'm going to look up nitroglycerin mass. And the mass of our nitroglycerin is 227. We don't have a peak that comes anywhere close to 227. The spectrum stops at 65. So you didn't have to do any of this other stuff at all. But I think it's good practice to do the other stuff. So, but you could have looked just at that and then use the other stuff to go off of it. So, yeah, this is a good example of using your problem-solving skills, using evidence to support your claim, which is what we need to do as scientists. So, I hope that was helpful. Good luck studying. Have a nice long weekend, and I'll see you on Tuesday.